Hey everyone, it's Mrs. Brimlow, and today I'd like to review with you how to solve two-step equations using inverse operations. There is a copy of the notes linked in Canvas, or you can just follow the video and then you can get a copy when you return. Okay. So, solving one and two-step equations. Now that we're in eighth grade, the expectation is that we're solving using inverse operations, working algebraically. We're setting that foundation for algebra and everything beyond. So the expectation is we're showing our work, we're solving it with inverse operations, which we'll review in a second, and we're showing all of our steps. If you're not doing that, you're not meeting the eighth grade level expectation. So you're not going to earn credit when you're graded. So it's really important as I'm showing you to show your steps, you need to do that as well. I know some of these review problems are easier problems. You might be able to do like this in your head, but that's not the goal. The goal is to train our brains to work and think algebraically and to be able to show our work and explain our thinking. Okay. All right. So an equation is a math sentence that contains an equal sign. So we're saying that two expressions are equivalent to each other. And the goal of solving the equation is to find the value of the unknown. We do this by isolating the variable using inverse operations. So when we're solving equations, we typically use variables or letters to represent our unknown values. And our goal is to isolate them or get them by themselves so we can figure out what they are. So we use what we call inverse operations. So inverse operations undo each other to help us work backwards and get to our unknown. So the inverse of addition would be subtraction. The inverse of subtraction would be addition. Inverse of multiplication is division, and the inverse of division is multiplication. So I like to think of solving an equation like a mystery. We have an unknown we're solving for, and we're using the clues and what we know to work backwards to solve the crime or solve the equation. I'm going to skip one-step equation since that's a sixth grade standard, so we should have mastered that, and I'm going to go straight to the two steps. Okay. So I'm going to just move this down. Okay. Solving two-step equations is similar to solving one-step equations. We will use inverse operations, except we need to undo two operations instead of one. So in all of these two steps, you're going to notice two different operations happening. Addition and multiplication, addition and division, subtraction and multiplication, subtraction and division, and then we have to work backwards. Right? So if we have a problem like number one, this is just a strategy. My job as your teacher is to give you all the strategies I have, and then you pick and choose what works for you. So I like to start by boxing my variable term. And so my variable term is 2x. My goal is to eventually have the x by itself. So before I can deal with what's inside the box, I need to get rid of the constant outside. So since they want us to subtract 9 in the original equation, we're working backwards to zero it out. We do the opposite or inverse. So we're going to add 9. Now, when I do that, I also have to do that to the other side of the equation. If you think of it like a balance beam, we have to make sure it stays balanced. Otherwise, or like if you go to the gym and you work out, you have to have the same amount of weight on each side. Otherwise, you're going to fall over and hurt yourself. Okay. So when I do that, okay, you could also draw a line too through your equals to help separate your sides so you don't miss anything. So 31 plus 9 is 40. Now negative 9 plus 9, those are opposites. So that leaves us with 0, okay? And then we bring down the 2x, what we haven't used yet. So 2x plus 0 equals 40, or 2x equals 40, which is what we want, okay? So this is 2 times x since they're next to each other. The opposite of multiplying is to divide. So I'm going to divide by the coefficient or the number in front of x. Okay, that leaves me with 1x or just x. And what I do to one side, I do to the other. So I would divide by 2 on the other side to get 20. Okay. So if I was to actually substitute 20 in for x, I would do into the original equation, 2 times 20 is 40, minus 9 is 31. That's a way you can check. You can write that out too, but just to check yourself. So this work, as I've shown you, this is the expectation. If you figured this out in your head quicker, that's great, but that's not what I'm looking for. You have to do the work this way and show it algebraically with inverse operations. This is what I mean when I say that. I'm going to skip the next one and I'm going to go to the third one because this is similar. So I'm going to have you try that on your own. Okay. All right. Now in this one, same thing. Box my variable term. Now in this case, it's going to be division I have to work with. Notice that it's written as a fraction. So first I need to get rid of this 6. So to zero it out, I do the opposite and I subtract. And what I do to one side, I do to the other. So 15 minus 6 is 9. Bring down that equal sign. 6 minus 6 is 0. And then I have x over 4. Okay. So now I'm really just left with x over 4 equals to 9. So x divided by 4, the inverse of that to get rid of that 4 would be to multiply by 4. And I do that to both sides to keep it balanced. So x is equal to 36. And if I double check, 36 divided by 4 is 9, plus 6 is 15. So I just substituted it back into the original equation just to check. Okay. I'd like you to pause the video and try the next two problems on your own. And then when you're all set, you can come back and check your work. Okay. All right. So in this second one, I'm going to box that term with the variable, and I need to get rid of this 13. So I'm going to add it to both sides. So this is negative 4x plus 0 equals 32. So I'm left with negative 4x equals to 32. Now you need to be careful here. When people see that minus sign, they think, oh, it's subtraction. That's not the case. This is a negative 4. The 4 is next to the x, which means it's multiplication when they're directly next to each other. So I need to divide by negative 4, okay? That way I'm left with just x because a negative divided by a negative is a positive. And I do the same to the other side. So my final answer is negative 8. Okay. All right. And my last problem. Now, you're going to notice that x over 5 is coming second in the equation. And that's not a problem. But you always need to make sure you take the sign in front of your term. So I'm going to box that negative sign, okay, or subtraction sign with my variable term. So since there's nothing in front of this 3, we assume it's a positive. So the opposite would be to subtract. So this leaves me with 0 minus x over 5 equals to 7, or negative x over 5 equals 7. Now, I want this to be a positive x when I'm done. So this is saying negative x over 5, or divided by 5, I should say. The opposite would be to multiply. So we're going to multiply by negative 5 on both sides. That's so we cancel out the negatives because it becomes positive, and then we also cancel out the 5s. So x is equal to negative 35. So if you need to, definitely brush up on those integer rules because we're going to see those come into play quite a bit throughout this unit. Okay. So if you check out Canvas, there are some different options to practice. If you have any questions, let me know, and I will chat with you soon.